here. We are the Italian Young Professional Network for the International Association for Hydro Environment and Research. Today, among us, we will have the pleasure to have Giulia Evangelista. Giulia is a civil engineer specialized in hydraulic engineering, and she did a bachelor degree at the University Politecnica delle Marche and hold a master degree at Politecnico di Torino. Now she's a PhD student at Politecnico di Torino, and today she will talk about the assessment of flood peaks attenuation performed by Italian dams. It is a very relevant topic today, especially in Italy, where we have a long drought period followed by floods, but this is also a relevant topic for any part of the world where water reservoirs provide several multi-purposes and multi-benefit, for example, flood control, hydropower, water for irrigation. So this is a very relevant topic, so we are happy to have Giulia here. And so, Giulia, the floor is yours. You can start.
Thank you. Okay, I'll show my screen. Can you see my screen?
Okay. Yes.
Yes, okay. Thank you, Emanuele, for your presentation. I'm Giulia, and today I'm talking about the large-scale assessment of flood peaks attenuation performed by dams in Italy, which is part of my PhD topic. So first, how do we typically assess the effects of dams on flood peak? We have a large literature about the analytical assessment of the alterations on flood frequency curves because of the dams, so downstream of the dam. We also have continuous simulation analysis, so we can stochastically produce rainfall time series and then generate hydrographs to be routed by the reservoir system. And we can also use synthetic indices. For example, the flood attenuation of reservoirs and lakes index developed within the flood estimation handbook. These indices aim to how can I say, roughly quantify the magnitude of the flood attenuation by dams. But both the analytical assessment and the continuous simulation analysis are hard to be repeated on a large scale because they are typically performed on the scale of single reservoirs. And as for the indices, some of them, they are qualitative indices, and some of them are developed by using regression analysis, for example, the index by Pig et al. So their use outside the range of calibration is a bit uncertain, how can I say? So we still do not manage the natural flood peaks attenuation by dams. And when I say natural, I mean the attenuation potential, which only depends on the features of the upstream basin on one hand, and on the geometrical features of the dam on the other hand. And why? So which are the goals? The first goal is very practical, is the ranking, so is sorting the Italian dams based on their attenuation capacity. And spoiler, this is what we talk about actually. And why? To identify target reservoirs, so a list of target reservoirs to be used for flood attenuation purposes. And we know that only about 4% of all the Italian large dams were built for flood attenuation purposes. And the other goal is related to wide area flood frequency analysis, because if I am observing a discharge time series at a gauging station, I want to know if this discharge is affected or not by the presence of dams upstream. So that's why we developed this approach to rank the Italian dams' performance based on their unsupervised attenuation potential. So we want to perform a systematic and homogeneous flood peak estimation over the whole Italy. And to do this, we need to know the actual rainfall extreme all over Italy. And because we are talking about the application in a wide area, we need necessarily to simplify. So we need to standardize the forcing hydrographs, and we need to introduce some simplifying hypotheses. We are using the numerical solution of the differential equation of lakes. And the flood peak of the incoming hydrograph is an index flood. So we are not considering any specific return period. And this flood peak comes from the rational method. And because we need to simplify, we are considering that the initial water level is equal to the elevation of the spillway crest, which is, let's say, the worst situation if we are considering flood attenuation, and we are considering only surface spillways. So no real gauge management are considered, and no low openings are considered, just surface spillways. What do we need to know to perform this ranking? Actually, just a few ingredients. We need the areal intensity duration curves, so the mean catchment IDF curve. We need to know something about the upstream catchment, so the runoff coefficient and the ingredient to calculate the time of concentration, so basically the basin size and the basin slope. And as for the dam, we need to know the lake area and the length of the spillway crest. This work is carried out on 265 dams, so almost half of all the large dams in Italy. These numbers comes from a number of criteria, so we are not considering the officially dismissed dams. We are not considering the retention basins, and we are not considering those dams for which we already know that we cannot obtain a good flood attenuation. So we are not considering those dams having a ratio between the lake area and the catchment area lower than a given threshold. In this work, the threshold is 1/150. So the final number is 2065. This approach is, of course, affected by some uncertainties. The biggest one is related to the time of concentration, because we are using the rational method, the rational formula, and we know that the flood peak calculated with the rational formula is strongly dependent on the time of concentration. So we are doing a simple sensitivity analysis. We are considering two formulas for the time of concentration. One is the formula by Pilgrim and McDermott, which only depends on the basin area. The other one is the Giandotti's formula, where the time of concentration is basically function of the basin size and the basin slope. The other big issue, let's say issue, related to the rational formula is related to the runoff coefficient. Because the choice of the runoff coefficient is basically subjective, so we are considering two possible values, 1 or 0.5. And also design flood, but also design rainfall. So we are considering two possible design rainfall. In the first rainfall scenario, we are considering local intensity duration curves. So for each basin, we know the actual A and N parameters of the IDF curve, or we can consider an average intensity duration curve for the whole Italy. So just only one value for the A parameter and one value for the N parameter. And finally, also the choice of the hydrograph shape is subjective, because at least in Italy, we do not have information about, systematically, we do not have information about flood volumes. So we actually don't know which is the best design hydrograph shape. So we are considering two possible shapes, a rectangular hydrograph and a NERC hydrograph. The NERC formulation is related to the features of the rainfall and to the morphological features of the upstream basin. So for all, and I forgot, by combining this configuration, we can calculate 16 possible input hydrograph to be routed by the reservoir using the differential equation of the lakes. So we calculate the attenuation coefficient for each of these 16 configurations. It is computed as the ratio between the outgoing discharge and the incoming discharge. So the lower the attenuation coefficient, the higher the attenuation efficiency. And this coefficient is investigated in terms of order position and magnitude. What does it mean, order position? We mean that for each of these 16 hydrographs, we obtain a list of attenuation coefficients. We sort each of these lists, and then for the same dam, we calculate the number of permutations between rank X and rank Y. And then we calculate if this ranking is stable or not. So here you can see some results, the graphs related to the ranking stability. In each of these graphs, we have on the y-axis and on the x-axis, the dam position in one of the 16 configurations. And the first row is for the rectangular hydrograph. The second one is for the NERC. First column, I'm using the same IDF curve, same climate, same formula for the time of concentration, but I'm changing the runoff coefficient. And we can see that the runoff coefficient has no effect in terms of ranking. So it works as a scale factor. Of course, it has an impact on the magnitude, on the value of the attenuation coefficient, because the runoff coefficient is strictly related to the incoming volume. But in terms of ranking, it has no effect. If we move to the second column, so same runoff coefficient, same time of concentration, but we are changing the IDF curves. So in one case, just one value for the AN parameter, in the other case, AN parameters which are local, so each basin has its own. We can see that the graph is a bit more scattered, so the variability is increasing. But if we move to the last column, so I'm changing the formula for the time of concentration, the variability is the highest. So the time of concentration is the variability, is the variables that most affect the variability of the ranking. Also, the climate has some effect, but is not the main governing factor. And another important result is about the shape, because we can see that for classification purposes, the choice of the hydrograph shape is not so important because the effects are quite the same. Of course, if I'm looking to the value of eta, of the attenuation coefficient, again, it has an effect, it's important. And also, if I am looking at single reservoir, of course, the choice of the hydrograph shape is crucial, but it's not crucial for classification purposes, for the ranking. So if we want to have a more deeper look to the morphological features, in the graphs on the left, you can see the empirical distribution function of the eta values, of the attenuation coefficients. Rectangular hydrograph is on the top, NERC hydrograph is on the bottom. And let's focus on the green and brown curve. The green one is for the Giandotti's formula for the time of concentration. The brown one is for the other formula, so just basin area is considered. And this type of graphs allow us to read on the y-axis also the ranking, because actually the empirical distribution function is basically the ranking, because I'm sorting a list of values. We can see 3 examples, the Lago Baitone, the Val di Noci, and the Alto Mora Dam. And you can see on the right where these dams are located. The Lago Baitone and the Alto Mora Dam are alpine dams. Their catchment slope is about 14–15%, while the Val di Noci Dam is located in Liguria, so catchment slope lower, about 4%. And all of these dams have an upstream basin which is about 5 and 8 square kilometers, so basically the same size. And we can see that for the Lago Baitone Dam, the difference on the y-axis, on the graphs on the left, is quite high. So if I consider the slope, or if I do not consider the catchment slope, I obtain very different results. While for the Val di Noci Dam, the green and the brown dots are close, so I do not have so big differences. And this means that apparently similar configuration of dams, because the Val di Noci Dam and the Lago Baitone Dam has a very similar ratio between the lake area and the catchment area, and also the same basin size. So apparently similar configuration of dam plus basin can produce different results if the morphology of the basin is different. And also the Alto Mora Dam, we can see that the gray dots, they are close. So again, I do not have so big differences, even if the catchment slope is high, is about 14%. But it's because the sensitivity of the ranking to the time of concentration is not important if the dam's structural features are not suitable for flood attenuation. So if in this case, if the ratio between lake area and catchment area is very low. So yeah, I really would like to go deeper in the details, but I can't because of the time. But we have submitted a paper about this topic. So if you are interested, hopefully you will find a paper about it. So for now, that's it. Thank you.
Thank you very much for the presentation. So now we can start the question and answer session. I don't know if someone has some question, otherwise I can start with the question. And yes, you talk about the importance of the ratio between the reservoir surface and the catchment surface. But why not considering the volume of reservoir instead of the surface?
Are you talking about the volume available for flood attenuation, or volume?
Yeah, the volume that is devoted to flood attenuation. Maybe.
Okay, we do not have this information systematically for all the dams. And as because we are considering a series of simplifying hypotheses. So, for example, the initial water level is equal to the level of the spillway crest. So our simplification is that the water is increasing like a square, let's say. Okay. So we do not know the real geomorphology, the real stage discharge equation. So that's why we are considering this ratio.
Yes, okay. And which database did you use?
This is a new database. Because yeah, this work is in collaboration with the Department of Dams and Hydroelectrical Infrastructures. So they provided us all the data, and lake area are calculated by DTM analysis.
Okay, because for example, there is the ICOL, the database, where for each reservoir there is also specified the function of the reservoir.
Yeah. Yes, it's because this work basically was born because the General Department of Dams and Hydroelectrical Infrastructure want to identify those reservoirs that they can use for flood attenuation purposes.
Yeah. Thank you.
Thank you.
I've got a question as well. Thanks a lot first for your presentation. It was really interesting. I've got actually general questions. I mean, I'm really interested in where your research is heading to. I mean, what are your next steps? What you're trying to do next? As well as I'm interested in possible application of your model and your results. So if you could give us some more information about that. Thank you.
Yes, as I told in the very first slide, the first one is a very practical, because the Department of Dams want to identify reservoirs to be used for flood attenuation. So this is very practical. The other one is flood frequency analysis, because if I want to know at a given discharge at a given gauging station, the flood frequency curve, I want to know if this curve is affected by dams or not. And also in this database, we also know when the dam was built, basically. So when the construction began and when it ended. Yeah, these are the main possible use of this work.
Okay. And are you also planning to consider at some point the, let's say, the operational features of the different dams? Because in your assumptions you mentioned that you're assuming the water level to be as high as possible, and also that you don't consider the, let's say, operational things about the gates and stuff. So are you planning to also model that at some point, or?
Yeah, of course, if I want to work at the national scale, it's very hard to consider the specific operational rules of each dam. But yes, because these results, these listed, of dams attenuation capacity could also be used for the not unsupervised attenuation, but to give some information about the supervised attenuation. So yes, it's very, let's say, ambitious if we want to continue working at the national scale, but yes, of course.
Thank you.
Yes, I agree that working at the national scale is quite complex. For example, I work at the European scale. It's still because there is still a lack of data, and much more than country scale. So we have always to do the right assumptions, simplifications, but at the end they give the right order of magnitude of the problem, and this is what is important.
Yeah. It's important because if we work at the national scale, we are working at comparative terms, and this is important. We don't mind about the specific value or the specific properties of each case. We work in comparative terms. Which dam can attenuate more than another one?
Yeah. Yes, I perfectly agree. And will these dams also be used for example, not only for flood control and mitigation, but also for drought control?
Mm-hmm. Yes. You said you're working at the European scale. Which database do you use for the European scale?
For example, we use we are not doing the same your work, but generally when working the European scale, we have 1 hour database for hydropower, but we also use the ICOLD database or the GRAND database.
Do you think the GRAND database is detailed enough for your purposes?
It depends. It depends because, for example, the ICOLD database has a lot of data also with the function of the dams. But for example, that I work a lot in hydropower, data that is missing is the head. There is the dam height, but not the head for hydropower, and this is a lack of the database. So we have sometimes we have to mix database, and so it's not so easy. So are there other questions? So I think we can finish here. So thank you, Giulia.
Thank you for inviting me.
The video will be then also on YouTube, so people can watch it. And so thank you very much, and hope to see you again at the next coffee break.
Thank you. Bye all.
Thank you. Bye-bye.
Bye-bye. Bye-bye.